So actually the periodic table, so writing the electronic configuration structure using a letter and the number. For example, as we know, oxygen is there. Oxygen is 8 and 16. So for oxygen atom, we have 8 protons, we have 8 neutrons, and we have 8 electrons. So we have to arrange 8 electrons. 1s2, 2s2, 2p4. So this number representing the shell number means this is the first shell, 2 is the second shell. And S and P is the name of a sub level, and how many electrons are there in each sub level, that's represented by a number as a power. And using a spin diagram or electron in a box model, so we have 1s which is having 2 electron, then we have 2s which is also having 2, then 2p. Here they give for fluorine, but what happened for 2p, it is having 4 electron. So how these 4 electrons will arrange in case of, so how these 4 electrons arrange in case of oxygen. So this is 1s, 2s, 2p. So first it will have 2 electron, one will rotate clockwise, another anti-clockwise. Then 2s2, one rotate clock, then 2p4. So first they will occupy singly, and then the fourth electron will be there, opposite spin, so that it can rotate and have opposite magnetic field, so it will have attraction. Then the whole periodic table is actually divided into subshells depending on, like example, this is called a p block element. Why it is called a p block element? If the last electron is in a p shell, we call that as a p block element. And where we can find the p block elements, we can find the p block element for group 3, 4, 5, 6, 7, and 8. So from group 3rd to group 8, these elements are called known as p block element. Then group 1 and 2 are s block element. Why we call s block element? Whenever you write the electronic structure or electronic configuration, you will find that the last electron is in s orbital. Then d block element, the transition element, if the last shell if the last electron or the which you write electronic configuration is coming in a d shell, it means it is a d block element. And if it's coming in f shell, it means it is a f block element. So whole periodic table is actually distributed as s block, p block, d block, and f block element. So if I write the electronic structure, say for aluminium, aluminium is 13 and 27. So it is 1s2, 2s2, 2p6, 3s2, 3p1. So when I arrange 13 electron, the last electron is coming in the p orbital. So where I will find position, I will find position of aluminium in this region. So where the last electron, when we write the electronic configuration is coming, that shows the position of the electron. Same way, if we write for iron, iron is Fe. So when we write in terms of energy, so iron is 26 and 56. So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So we arrange 20 electron, and then 3d, 6. So the last electron, when we write in terms of energy, is coming in a d orbital. So where we can find this? We can find in this region. So the whole periodic table is actually divided into blocks. If the last electron, when we write the electronic configuration, is coming in S shell, we call that as S block element. If it's in a P shell, we call P block element. If it's in a D subshell, D block element. And if it's an F subshell, we call them as F block element. Then the shapes of these orbitals, say shape of S and P, you should learn. S is spherical, where P is dumbbell, and P is actually divided into Px, Py, and Pz. So actually, this region can have 2 electron, 2 electron, 2. That's why the P maximum can have 6. So this is Px, Py, and Pz. Collectively, when you combine, it will become P, and maximum it can have 6 electrons. Each orbital can have 2, and total number of orbitals in P subshell are 6. That's why maximum it can hold 6 electrons. So 2 in each. There are 3, so there are like 2 electrons here, 2 electrons here, and 2 electrons here. So when combined, will make a P. That's why P can hold 6 electrons. And S is a spherical. So as S is spherical, it will be like a sphere. But what will be the difference between 1s and 2s? Both will be spherical, but the 2s will be far away from the nucleus, so its size will be bigger. Is it clear? The idea, the concept of orbital? So I want you to write the electronic configuration for a practice, because the other part is related. So I want you to write the electronic configuration for first 20 elements as a homework and send it on WhatsApp. Of first 30 elements. The electronic structure for first 30 elements of the periodic table. That's a practice. So as we discussed earlier, how to write the electronic structure. Then ionization energy. What is the ionization energy? First ionization energy. It is energy required to remove electron from a neutral gaseous atom. Like example, we have sodium and we have chlorine. So ionization energy means when we have sodium atom in a gaseous state, or we have chloride atom also in a gaseous state, how much energy we supply to this sodium or we supply to this chlorine, so that they will lose their electron. So when they will lose electron, whenever anything, even it's a metal or a non-metal, the general tendency of a metal is to lose electron and non-metal is to gain electron. But the term ionization energy means energy required to remove electron from a neutral gaseous atom. So when we remove electron from sodium atom in a gaseous state, or we remove electron from chloride atom in a gaseous state, both will get a positive charge, and we remove one of the electrons. So what we call this? We call that as first ionization energy. You have to learn the definition. What is the meaning of first ionization energy? It is energy required to remove electron from a neutral gaseous atom. But what is second ionization energy? We already remove one of the electron from this sodium. So how much energy is required to remove another electron so that this sodium will get a +2 charge? So energy required to remove another electron from this sodium, that is called second ionization energy. If we remove another electron, what we call that as third ionization energy. So energy required to remove electron from a neutral gaseous atom. If you remove one electron, we call first ionization. If electron is already removed and we remove another electron from the singly positive charge ion in a gaseous state, we call that as second ionization energy. And what we observe in terms of group, so what we observe ionization energy as we go down the group. As we move down the group, what we observe, ionization energy down the group decreases. What is the reason why we go down the group, the ionization energy decreases? Because the size of the atom is getting bigger. So as the size of the atom is increasing, so it will be easy to remove electron from the last shell. The distance is increasing. So it will be easy to remove electron from the last shell. That's why the ionization energy, as we go down the group, it is decreasing. So there are two reasons. Number one, why it happened? Because greater the distance between electron and nucleus increase. So less energy is required to remove electron. That's why this is one reason. What is the second reason? The second reason is known as shielding effect. What is the meaning of shielding effect? What happened? Because there are more electrons close near the because there are more electrons in inner shell which repel the outer shell electron. So it can be removed easily. What is the concept of a shielding effect? Like example, if this is a nucleus, so this is a nucleus for all these. But as you can see, as we go down the group, the number of shell increases. So this was having one shell inside. This is having two shells inside. This is having 3 shells inside. And each of these shells, what they have electron. So this will have 2 electrons. This will have 8 electron. And this will have more electrons. So what these electrons will do, these electrons will repel the outer shell electron, and when the outer shell electron will experience repulsion from inner shell electron, what we call this effect? We call this effect as shielding effect. And shielding effect increases as the number of inner shell electron increase. Is it clear? Is it clear, this idea about the shielding effect? So reason, if a question is give reason why ionization energy decreases as we go down the group. So one, you'll mention the distance between electron and nucleus increases because there are greater number of shells. And the second reason is about shielding effect. And when we move across the period, as we move across the period, what we observe ionization energy increases. Why the ionization energy increase as we move across the period? Because the size of atom is getting smaller and the charge on the nucleus is more. So the nuclear charge is increasing and the size is, so if a question is why it increases, because nuclear charge means it's about protons. So example, if this was having 1 proton, this will have 2 protons, this will have 3 protons in the nucleus and 4 protons. So what's the reason? Because greater nuclear charge and small atom size increase attraction between nucleus and valence shell electron. So it requires greater amount of energy to separate the electron or remove the electron from atom. So these are the reasons which you have to learn why the ionization energy decreases as we go down and why it increases as we move across the period. So as we move across the period, the nuclear charge is more, there are more particles inside the nucleus and the size of atom is smaller for the same shell. So it is closer, so greater attraction, which result in higher ionization energy. Is it clear? This concept of ionization energy and the trend in ionization energy down the group and across the period. Any doubt in this? Okay, so I'll end this session now and share the recording with you. Still, this topic will continue next week. It's related to ionization energy.